So for example, to show you how you will make it work, regardless the number was stored over here or not, you will write some code like this. If a list of 2 is int. Okay, if that's the case, then what will you do? Int num equal to int of a list of 2. So again, you can use the is operator or the as operator or reflection to figure out, is it really pointing to an integer? Okay. So once again, keep in mind, is, as, reflection are expensive runtime operations because they have to go through the vtable to the type info to actually find out it is pointing to an integer, right? Okay. So anyway, now let me come to a loop. And let's take a look at the same example. And so let's make it even interesting. Let me create another example so that everybody can fully understand it. Okay, so let's create an example. Suppose it looks like this, array list. A list equal to new array list. So we create an array list, right? Then we say, let's create a student. Student S1 equal to new student. And suppose we set test1 equal to 89, test2 equal to 91. Okay, and the formula goes like this. It's 0.4 times test1 plus 0.6 times test2. If that's the case, if it's greater than 90, then it's an A grade. Okay, so that's how the compute grade was written. Okay, so then we do a list.add S1, correct? Now we create one more student, S2 equal to new grad student. Okay. We do S2 dot test1 also 89, S2 dot test2 also 91. Okay, and let's pretend for the grad student it's 0.5 times test1 plus 0.5 times test2. And if this weighted average is greater than 90, then student will get an A grade. Otherwise A minus. Okay, and so on. So now let's go a list dot add S2. Okay, so suppose our goal was to loop through the array list. So now let me come to the loop and call compute grade or print the grade of every student who's stored in the array list. Okay, so we can write a regular for loop. Our regular for loop will look something like this. For int I equal to 0, I less than, we called it a list dot count. So just like an array has the length property, the collection, all collections have a count property which lets us know how many elements are stored in the collection. So in this example, what will be the count? 2, right? Because we stored one time S2, one time S1, so 2. So it will go through I of 0 and I of 1. Okay, so first time through the loop I will be 0, second time through the loop I will be 1, right? So what if I did something like this, message box.show, and a list of I compute grade, what will happen? Will this code compile or won't even compile?
This will come.
Okay. What data type is a list of I?
Object.
Object. Remember, if anything that's stored in the array becomes an object, so it's an object. Does an object have a compute grade method? So the code won't even compile, right? In this example, we know everything we were storing in the array list was a student, right? What if we do this? We typecast it to a student. So we typecast it to a student. And then further, let me put one more parentheses over here, one more parentheses over here. So see, now if you take a look at inside the parentheses, we converted object to a student, correct?
Yeah.
Now if we call compute grade, remember this has become a student now. Does student have a compute grade?
Yes.
So it will work. So first time through the loop, what will it print out? What grade will it print out in this example? A. Second time through the loop, what will it print out? No, because 0.5 times 89, 0.5 times 91 is exactly 90.
Yeah. A-.
But we have to be greater than 90 to get an A.
A-.
So it will print out A minus, right? Okay, so that's one way of looping through, right? There's another loop, as I mentioned, there's another easy loop available, especially for dealing with collections, called the for each loop, okay? The for each loop looks like this, for each student ST in a list and message box dot show SD dot compute grade. Okay, so this is what the for each loop looks like. Okay, to understand the for each loop, let me draw the picture. Right now, you have S1 stored over here, you have S2 stored over here in the array list, right? So think of this for each loop as student ST. We are creating a reference called ST, capable of pointing to a student. Once we say ST in A list, what it will do is, very first time through this loop, it will point to the first element. Okay, is this a student? Internally?
Yes.
Yes. I mean, even though it's stored as an object, internally it is a student, right? It will call the compute grade and it will print out just like before an A. Okay. Then second time through this loop, our reference will change to the second object in the list. Is this also a student?
Yes.
Yes, so we'll call the compute grade on it. It will print out A minus over here. So which one of these is easier? The for loop or the for each loop? For each is easier, you don't have to worry about typecasting it, right? However, in both cases, we can run into a complication, okay? So for example, suppose this code was working perfectly, okay? Then somebody went and added one more thing to the array list. And let's take a look at, in both situations, what will happen. So now, let's go to this part over here. Okay, very first time through this loop, it will go to a list of 0, right? This is index 0, this is index 1, this is index 2, correct? So, as we are looping through this one, count, of course, is 3 now because there are 3 things stored in the A list, right? Very first time, A list of 0. Can we convert this to a student? Can we typecast it to a student?
Yes.
Yes. So we'll print out
A.
A. Second time through this loop, I will become 1. A list of 1. Can we convert A list of 1 to a student?
Yes.
Yes. So we'll call the compute grade, and it will print out A minus. Third time through the loop, when I becomes 2, A list of 2 is what?
Hello.
Can we typecast it to a student?
No.
So what will happen?
Runtime.
Runtime error will occur, so your program will crash after it goes third time through the loop. Okay, let's go to this scenario over here. Okay, again, very first time through the loop, ST will be pointing over here for each student ST in A list. So first time through this loop, it will point to S1. It is a student, so it will print A, no problem. Second time through this loop, ST will point to the second object. It is a student, it will print A minus, no problem. Third time through the loop, can ST point over here
No.
to a string?
No.
So again, it will generate a runtime error, right? So in both cases, we have to check before we blindly either typecast it or try to call a method on it, okay? So the proper technique in both cases will look something like this. Here you will say, for example, you can do student ST, well, let me call it student STU so that you don't get confused, equal to A list of I as student. Okay, if STU not equal to null, then message box dot show stu dot compute grade. So we will change the code to look like this. Okay, now let's take a look over here.